I want to welcome Paul Laviolette. This is Carrie Cassidy from Project Camelot. We're going to be doing an update on our most recent interview with Paul, which was about in December, I believe, of 2013. So just the end of last year, and this is now March. And Paul had made a number of statements about something possibly happening in April with regard to the superwave, or what might be a gravitic wave, if I understood it correctly, coming as a result of the G2CLOUD. So right now what I'm doing is putting this graph on the screen. Maybe you can explain what this is all about and why it might be important for people to take a look at. And also, I guess before we do that, Paul, if you want to give yourself a brief introduction for the people that are not familiar with your work, that would be great.
Well, I've been researching the galactic core and superwave idea for, well, since I was doing my PhD back in the late 70s, early 80s. And it was at a time when the general opinion was that our core, if it does explode, maybe every 60 million years, so we don't have anything to worry about it. And if there was an outburst, the general view was that it would be contained in the galactic core region. It wouldn't reach us. So as if we were immune to any problems here. Since that time, we know about gamma ray bursts, which most of them come from other galaxies, and they certainly affect us. In fact, one that was from our galaxy affected our satellites. That was in 2004. We had a tsunami about the same time. Whether there was a link, we will not know, but it's an interesting coincidence. So anyway, over the years, this is one of the main things I've been working on, and formed the Starburst Foundation for promoting this awareness, because nobody seemed to be aware that this was a threat to the Earth. Most of my work back then was looking in the past at what happened at the end of the Ice Age and during the Ice Age. And a little for the time since then, there apparently are some small events that have occurred since the ending of the Ice Age, something like 13 of them. And now scientists have begun to discover events in the ice record, in the tree ring record, that can't be explained by other causes like supernova and so on. And they seem to match up with the dates that I was talking about way back. Now the new thing, well, up until recently, when people would ask me what is the chance of a superwave occurring, I would just say we're overdue for one, because if you look at the past record over the last 6,000 years, these small events at least come about every 500 years, and we haven't had one for 700 years. So I could only say, well, maybe 90% chance in the next 4 centuries. But now things have changed with the G2CLOUD, because here we see something that could pose a threat. We're now concerned if there's a binary star hidden inside the cloud. And if so, then the probabilities go way up that something could happen. So that's where we are now. The last couple of years, we've become aware of this, just before 2012, really.
Okay, and most recently, you sent me a bunch of links, and we did post them for people to sort of review them leading up to this discussion. I guess you might say some background. Do you want to go over some of the background of why this might be a problem? Like, in other words, last time you described very well, I thought, the process of what happens when this body gets close to the, or sort of circulates around the galactic center, if it does exist? Can you kind of review, go over that briefly?
So you'd be interested on the effects on the Earth, or what happens when it gets close to the core?
Yeah, what happens, first of all, what happens, what's the dynamic out in space, so that people can visualize. It helps them to visualize why this might even affect us, this body within the G2 cloud getting close to the galactic center.
Okay, well, astronomers now have come to agree that there's very likely a star hidden within the cloud. It's just that some of their theories about this are a little off. Like, for example, they are under the impression that as this star gets close to the core, that the cloud will be dissipated by the tidal effects, that it sort of become elongated and dissipate, which I don't see happening because the star, in my opinion, is continually generating that cloud. It's an active generating process. It's not like there's a star and just happens to be in a cloud. The cloud is not stuff that's gravitationally attracted to the star. It's stuff that's being outgassed from the star. Stars don't behave as normal when they come close to the galactic core for a number of reasons. First of all, they're being heated by the tremendous X-ray or cosmic ray flux that's coming off of the core that we can't really see. We can only infer that it's there based on X-ray emission. And I believe that the standard assessments are a little sort of lowballing the figure, that it's a lot higher than they are saying. Now, these cosmic rays would go into the atmosphere of the star and heat up its outer regions of the star envelope. But in addition, there's what I call genic energy, and that's most of the stars in the sky, they're the red dwarfs, they're entirely powered by what I call genic energy, and that is spontaneously generated energy. Now, that's a new physics concept. You won't find it discussed in standard physics. It has to do, to understand what I'm talking about, go to subquantum kinetics, and I've made a whole number of predictions based on this idea. The more recent one being the pioneer effect. I predicted the pioneer effect before it was discovered, and it confirmed what I was saying, that in the galaxy, energy tends to increase over time. The photons will blue shift, so stars will be generating excess energy. Our sun generates about 15% of its energy is genic. The other 85% is fusion, as conventionally believed. But in the case of a star, when it comes close to the galactic core, the genic energy will go way up because it has to do with gravity potential. As the star gets into regions of deeper gravity potential, more negative gravity potential, the genic energy, the formulas predict genic energy will go up accordingly. So by the time it gets to pericenter, the closest approach, its genic energy production will be tenfold higher than it was when we first discovered this star. So all this, what it does is it's energy that's coming from within and inflating the star. And this will be more important for the lower mass stars than the higher mass stars, but it will sort of inflate it and cause it to be losing its atmosphere as we observe. That's the cloud being formed. So as this comes in close to the core, the question is it really more than one star? It could be a binary star. There's a big probability that it is. If it's not two stars, it's very likely a star with planetary companion, like a Jupiter-sized planet, and there would be pretty much 100% chance that it had a companion, at least like the size of Jupiter or larger. Could be a brown dwarf. maybe 50%, 60% chance that it is a star as a companion. So if so, when it comes to pericenter, there's the chance that that will be tidally ripped off and come hurling in towards the core. And at that point, there's several things that could happen. One is that it gets flung out into space as a hypervelocity star, which means it'd be leaving the core at very rapid speed. The other is it could go into orbit, in a new orbit around the core, different from the G2CLOUD orbit. And the other is that it could hit the core and cause an outburst. So that's why on my website I compare it to a pinball game. You don't really know if you hit the goal. In this case, you don't want to hit the goal. So you can only put percentages. And unfortunately, nobody has done any computer simulations on the G2CLOUD with the idea that it might have a binary star in there to see what would be the chances. They have done computer simulations on stars in general in the core, but nobody has worked on the G2CLOUD. So we're a little, without information to guide us on this. All you can say is you look in the past and you notice, well, there are these stars orbiting the core from past encounters. They call them the S stars. And there is no star in its orbit that comes closer than 80 astronomical units, which what that means is if there was a star that came closer, the reason you don't see it is either it got consumed by the core or it got flung out of the galaxy. And that's why you don't see it orbiting. Now, the one that we're talking about, G2CLOUD, that's predicted to come, about 150 astronomical units, so about twice that distance. So we're in the, close enough that it's uncomfortable, and close enough that if it did have a companion, very likely it would be stripped off. So then at that point, if it does become stripped off, and the question is, would we have warning? If it was a large enough star that was stripped off, you'd see another cloud separating from the G2CLOUD. Astronomers could see that if it happened. But if it was a smaller star, it wouldn't be putting out as much gas, and it's possible they wouldn't see any cloud, because we're talking about something that's 23,000 light years away, and these things are difficult to resolve. So if it was, for example, a planet, it could happen that it gets stripped off and we wouldn't even know it. And then the first thing we would find out when something was happening is when that planet reached within, let's say, 20 or 30 astronomical units of the core. When I say astronomical unit, I'm talking about AU, astronomical unit, is the distance from the Earth to the Sun, to give an idea. And our solar system's about 30 astronomical units in radius. So when this gets, if you can imagine the galactic core being where the sun is, and something coming in as close as around Neptune, very bloated and getting tidally ripped apart at that point. But it's coming in, hurling in at like a good percentage of the speed of light. I forget what it's posted on the website, what my calculations were. I think it was at least 10% the speed of light. So you don't have much time before it hits. So I was figuring maybe 2 days at that point. So if there was a lot of X-ray emission from that ripping apart of the planet or star, at that point, we'd have 2 days before the outburst would, if it hit the core, if it was within the capturing radius of the core. So, one way of knowing is to look at the X-ray data, and I can show you the latest. They put it up every day. Yeah, I don't know if you can see this. It's posted on the website. I don't know. You know this curve is from the Swift telescope.
Right. I think I have it here. It's the link you last sent me, right?
Yeah.
Okay. So
there was one that had the day before, but it's pretty much the same yesterday's and today's.
Okay.
And we don't see anything happening. It's hidden under the emission from a what's called a magnetar, which is very close to the core, and it's so close they can't separate its X-ray emission from the core X-ray emission, because the magnetar had an outburst a year ago, and it's calmed down, but it's still 3 times higher than the core emission, and so we'll only know if things are acting up when the core has an outburst that's like 5 times normal, at least. So as of this point, it looks like things are still calm the way they were a year ago.
Okay.
And
well, this is very interesting. Now, in terms of what may happen, are you feeling that you're still in the same place where you were when we spoke last? In other words, or do you feel that you have gained more data since then that has led you to believe, something else, or brought you down that road a little further? And if so, what would that be?
I've been interacting with astronomers about this. I sent emails back in January to about 70 astronomers who have written papers about the galactic core and G2CLOUD. And I was telling them about this idea of the binary star being hidden, because nobody had brought it up, that there might be a binary star in there, and if so, it could get ripped off and we have an outburst. So the first 15 emails I sent out, I did them in batches. I did get 3 replies back from astronomers, and all of them were positive. They thought it was a very interesting idea. I should publish a paper on it. Of course, it wouldn't have been time to publish a paper. By the time it's reviewed and everything, whatever happens is going to happen. So I thought the best way would be to just email them the idea, so it was in people's heads to be watching it. And in the emails, I was asking them, if you see any evidence of a cloud separating into 2, please let me know. So these 3 said they would let me know, which was very nice of them. And it gave me encouragement that none of them thought it was a weird idea. One did have questions about the idea of a binary star, but I think I addressed his concerns pretty well. But then the other batches that went out, I got 0 replies, and I don't know why. I mean, statistically, you would have expected another 10 replies at least, but there were 0 replies, and I don't know if somehow there was some sort of the word got out that I was sending a similar email to a lot of people and not to answer. I don't know what the reason was, but at least a certain number, I believe, got the message. Now, since then, I did send, oh, by the way, I had my paper attached, or at least a link to my paper where I was talking. Now, this is a paper that was published in the 80s in a reputable journal, Earth, Moon, and Planets, talking about the superwave idea, and the idea that cosmic rays from a core outburst could propagate rectilinearly towards us at the speed of light. Which means that when we see the outburst, if we do see an outburst, the cosmic rays will be on our doorstep. And none of the astronomers were seeming to they didn't give the impression that they were aware of this. They're in their model that they have. probably see this happening either if there's going to be a jet, it's going to be towards the galactic pole and never be directed in our direction, or the cosmic rays would diffuse over millions of years before they reached us. So it's sort of like Godzilla and Bambi, you know, just there's these innocent people expecting they would like to see an outburst, so for their reasons of science to study what happens, and not realizing that they're standing right on the rim of the volcano. And if it does, they're going to be in serious danger. Like what happened at Mount St. Helens, I think there was somebody that lost his life. He was a little too close to the volcano, scientist.
Okay, well, let's go down that road then. So let's say this does happen, and you're saying, are you saying in April? You have a target date, I believe, sometime in April. Am I correct?
Yeah, but beginning as early as a week from now to the third week of April would be the time when this would be at its closest point. We can't say definitely. It's based on different estimates, and there's plus or minus in there. So if you figure all that, you have to put this range on. Then you add another 2 weeks for the star or planet to make the journey into the core. So that's about the time frame when you can expect. So we can't be really more accurate than that at this point, till more data comes out.
Okay, so what we're saying is with relative certainty, you're saying that there is a binary star, or there is at least one star, possibly binary. Is that correct?
Yeah, I don't know, 50 or 60% chance it's a star, and 100% chance a large planet or brown dwarf. So even the planet or brown dwarf could create an outburst if it makes a hit. You know, and I'm saying maybe it's a 3 to 7% chance that the G2CLOUD on this pass will have something stripped off and cause an outburst. So it's not a big probability. And I could be wrong. It could be bigger, maybe, you know, because we haven't done any simulations on it, unfortunately. That would be the only way to make the probability more fine-tuned. So all we can do, you know, we should be prepared for something. You know, if it's a small, if we look at the past record, there have been small events. Most of them, I posted a list of the dates. And a lot of these, half of them have been matched up with events in the ice core record or in the tree ring record, where they did see a spike in carbon-14 or beryllium-10, which are produced by cosmic rays. And these events were not attributable to other causes. And they didn't know what caused them, but they did match with these dates that I had predicted. And well, some of these are within historical times, and we didn't see anything major climatic happen except the one 5,300 years ago, which interestingly coincides with the beginning of the Mayan calendar chronology for this cycle. The Mayan calendar began about 100 years later after that. You know, you can imagine things died down, so people started the calendar at that point, as did the beginning of ancient Egyptian civilization. The rise of, look at the radiocarbon dates of the Nile Delta, and you see a rise of the number of campfires and so on, and remains after that date. So it's sort of like after that event passed, things became okay on Earth for civilization to start, it seems. But looking at the past records, like, you know, people, like if you look at the comments on our postings, you get some very interesting discussions going on. And like, for example, one person was wondering about, would this cause an ascension type of phenomenon where suddenly we pass into another dimension and so on. which is something that people predict will happen in the future. But if we look at the past, we don't know of anything like that happening, at least in recorded history. The last one was 700 years ago. In fact, there's no awareness people don't seem to have been aware of anything like even a bluish star showing up. At least there's nothing in the records. It may have caused auroral displays like we're having now, but what we're having now is due to the sun. But a superwave can produce auroral displays too. So it could have had that effect. So it'd be interesting to check historical records about auroral displays if there's information about that.
Okay, but at this time, what you're saying is, you're doing these observations. In a certain sense, you're out as kind of a lone gunman out there doing all of this. Is there really no other scientist paying any attention to any of this?
You mean as far as superwaves and the G2CLOUD? I don't think there is. Yeah.
Very interesting.
And I try to do what I can to inform the ones there about my theory. More recently, after that series of emails I sent out, I sent to 3 others, one being the astronomer that's heading the Swift X-ray telescope observations, and then a couple others who are leading groups in doing infrared observations of the Galactic Center, and got no reply back. And I pointed out, I was a little more specific there, not just talking about binary stars, but saying, look, are you aware that if this does produce fireworks, it could be something serious? You could be yourself in danger, your team, and the rest of the world, in fact, and your telescope feed will get cut off the moment this happens, because your satellite's going to go out. So you will have no further information on it. It would be something similar to what they predict for a Carrington event as far as satellites go. And even the small events we're talking about, the last one being 700 years ago, could have that effect. It's just we didn't have modern technological society at that time to see that type of effect. But now we have electric grids, satellites, cell phones. All of this could suddenly grind to a halt with an outburst. And that's what's the real serious thing. I mean, it doesn't have to be so strong that it kills us as far as lethal dose. It very unlikely a superwave in our galaxy would have that ability, although I would stay indoors for the first 3 days. That's when these superwaves are the strongest. And at least have shelter of your roof, because that would stop the electron component. But the thing to worry about is, what happens for the people that don't have alternative energy. All these years have been this effort to get alternative energy, and that did have a good intent besides just getting us off the grid. I mean, for safety, that would have been good if governments had promoted that more. So the other thing is that if there was a gravity wave associated with this, and that could arrive without warning even a day before the visible electromagnetic part, and that could cause earthquakes around the world.
Okay, so is there a place on your website where people can go to have you put any kind of photographs of or drawings of this sort of progression that may be occurring?
Well, I did have one image here of how this binary star could get stripped off. I don't know if you can see this.
Yes.
This is talking about what's called Lagrange point. You see where that bottleneck area is. To the left would be the galactic core. To the right, that red thing would be the star. And if the companion was outside of that bottleneck in the other region, it would get pulled into the core. So this all depends on the mass of the companion star and how far away it's orbiting from the primary star, also the mass of the, well, mainly the mass of the primary star and the distance the companion is from the primary star. These two things are what determine whether that star companion will be outside that Lagrange point and get pulled away.
Okay, just curious, you're saying that the G2 cloud actually comes from the star itself that's within it. Is that's what you're saying?
Yeah, it's sort of being boiling off continually.
Okay, that's interesting because, I had gotten some whistleblower testimony about the G2 cloud quite a while ago and been putting out information periodically regarding that. So I know that at least as far as my whistleblowers are concerned, at least, one or two of them, your information about the G2 cloud is accurate, and you can go on the net and also, research the G2 cloud. What they never talk about is, that it might contain a star or a planet, as you say. And you're actually saying whatever it contains is actually generating it, which I find really interesting. So they sort of emphasize the G2 cloud does exist. It is, I believe, crossing the galactic core, but they don't talk about the body within it. And I'm also wondering whether or not this phenomena has anything to do with, and I know people will wonder this, Planet X, Nibiru, an incoming body that has been said to be incoming to our solar system. Lots of rumors about this sort of thing of all kinds. Do you think that there's any correlation?
I wouldn't think there would be a correlation. You can look at some things like the orbit of the planets around the sun. There's a node, which means the planes of orbiting of Jupiter, Saturn, Mars, so on. They cross the ecliptic in a certain region of the sky, roughly. And that region's aimed towards the galactic core, which is very interesting. So what that means is that the whole solar system has been acted upon gravitationally by something coming from that direction. And that doesn't need to be continuous, can be periodic, like superwaves, gravitational waves associated with superwaves. All of the stars in the galaxy, they're moving away from the core. Why is that? There's a radial velocity. But if a gravity wave hit us from the core, it would propel us away from the galaxy. And this is part of the reason why our galaxy looks spiral. This happens in every galaxy. Something has to keep pushing the matter, the stars out. Otherwise, the spiral arms are going to wind up on themselves. People have done simulations of that.
Okay,
but as far as Nibiru, that would be, I think, separate issue. But you can show some effects on the planets by this.
Okay, so is this, when you say there's probably no correlation, is this because this G2 cloud is too far away for this to be the same phenomena, or is there another reason?
Well, first of all, you have to say, does Nibiru really exist? I don't know that it's been proven to exist.
Sure.
There's a period of, 3,600 years that it's supposed to orbit the Earth.
Or 2,600.
So you should, or what?
2,600, but I'm not really good with numbers. So.
I thought 3,600.
Okay.
Remember.
Fine.
So if that was the case, you should see some effects in the ice record or tree ring record at that frequency.
But I take it you haven't researched that part. You haven't researched anything
Oh,
about an incoming body aside from, in other words, that whether they call it Nibiru or whether it's just some incoming body that is particularly large. I've heard, it called Jupiter-sized. There was quite a big deal about this so-called Planet X a while back, but it was never really resolved. But in terms of the galactic core, I thought that there was a periodic record of some kind. I just wondered whether you had investigated that.
well, only like everyone else, you hear about this, you investigate it to a certain point, but I don't spend a lot of my time on that.
Okay.
My work's not so much on following comets and planets and dark stars around the solar system. That I've sort of tried to specialize in what I'm doing.
Okay, but it's so you ended up finding out about the G2CLOUD and then the bodies within it. How did your interest get stimulated by that particular phenomena?
Well, I heard about the G2CLOUD in the news reports, and people help out. They'll send me news announcements that I wasn't aware of because I don't spend a lot of time looking for the latest news announcements, and sometimes people send me something I didn't know about. And when I saw it, I thought, well, this is very important. This is the first time we've heard about this sort of thing. And, I formed the Starburst Foundation one of the purposes was to alert people if the world would be in danger from a superwave. And here was a way to know in advance that there was a certain chance we were in danger. So, that's part of my work is to do this. And I'm hoping also to go on other talk shows now to spread the word about this. I'm not trying to say something 100% will happen. It's just we should be aware. And if something does happen, not blame it on God or that we were bad people. This is a phenomenon that's natural. It's just the only thing is our stupidity. We have not been more aware of the whole phenomenon.
Okay, well, speculative.
Media is hard to blame.
Absolutely. Speculatively speaking, would you, I know you don't have any interactions really with the sort of secret space program, or call it what you will, that scientific community that is most likely to be aware of the things that you're talking about. But I'm just wondering, have you thought about or even tried to contact them or felt that in other words, there are preparations being made that people have talked about and so on all around the planet? And do you think that some of those preparations may be aimed at their knowledge of this phenomena? Have you gotten, since we've last spoke a long time ago, I interviewed you in a very in-depth interview about your work, I believe, and you had talked about the fact that you really didn't have many inside or any inside sort of contacts. Has that changed?
Not recently, but a few years ago, there was a fellow that was trying to get me interested to, I don't know, he wanted me to somehow make some agreement with him to work on advanced technology and giving the impression that he had a lot of access to a lot of money. And he started at one point bringing up about this facility in Montana somewhere in a abandoned gold mine where they've made real estate a mile underground or more, it's available for people to have the money to rent space. And he didn't come out and say it, but it sounded to me that he was quite afraid that something is going to happen pretty soon, and that he himself had and his group taken this real estate, and with the idea, join us and you'll be safe. There was somehow this message coming across, which I could really give a darn, about this. If I feel I'll be guided to be where I'm supposed to be if something happens.
And you live in Greece, just that you're in Greece and you're actually very close to the coast.
Well, right now I'm in Athens,
Okay.
So inland a bit.
Right.
I have the Lycabette Mountain to my south, so I think might shield me from the core if because if this happens, the outburst would come from the direction of the galactic center, which is between Scorpius and Sagittarius. So if you can picture where those are in the sky, I don't know if you have one of these iPad programs you can hold up and it tells you where the constellations are. You just aim it in a certain direction. So that part of Scorpius and Sagittarius would be if you were at 45 degrees latitude, as an example, it would be about 15 degrees above the horizon, because this is quite low. It's below the ecliptic, this place. So if you had, let's say you lived behind a mountain and that was on your south, you would be shielded from the direct outburst, although cosmic rays have a habit of turning the magnetic field lines, and so eventually the lower energy stuff would come from all directions. But at least the high energy ones, the bullet-like ones, you could be perhaps protected if you're on the north side of a mountain.
Okay, but can you describe those cosmic rays or those incoming rays? I mean, you've described some of the effects, but I mean, is this something that we would actually see, or is it only the effects? And are the effects possibly subtle? In other words, satellites don't operate. Would it actually take down satellites? Would they fall from the sky if they were impacted?
Well, it would fry their electronics unless they were hardened for EMP. Now, military satellites, I don't know. It's classified, so I wouldn't know. It would be nice that at least we would have military satellites functioning at this point, so that there would be some backup communication system in the world, at least so governments could tell each other this was not a nuclear attack. Stand down, because that was an issue back in the 80s. That was one reason the Starburst Foundation had contacted the UN and the US, a number of other countries, to let them know, if something like this happens, don't launch nuclear weapons, because it was before the complete disarmament took place.
Okay, well, what about incoming bodies? In other words, like small meteors or asteroids, would this wave carry with it debris?
If it was large only. If it was large and lasted for hundreds of years, then this continual, the continual bombardment by cosmic rays is going to create like a wind that would blow cosmic dust in fact, generate cosmic dust from frozen material. Now, whether the gravity wave, even from a small event, would the gravity wave push stuff that's nearby, even, the Earth is, we've got a lot of junk out there, space junk, not man-made, but stuff that the Earth's picked up. It forms a veil around the Earth. A lot of people don't know that. They have a name for it, circumterrestrial dust sheath. I guess it's something like that is called. It's stuff that gets caught in the magnetic field of the Earth, because a lot of this dust gets charged by ultraviolet light, and if it gets captured there and builds up and builds up. In fact, there's a I believe that when the field collapsed at the time of the mass extinction, I believe there was a huge solar flare that caused disturbed the Earth's field. That a lot of that junk got thrown into the Earth's atmosphere, and that's why the group in California mistakenly thought it was an asteroid or comet that hit the Earth. They found a lot of iridium. Now, all that stuff is out there around the Earth and could easily come in if there was a disturbance of the magnetic field. As far as comets, maybe you could get a few if there was junk just floating near the Earth that got some impulse, radial impulse, and threw it toward the Earth. But we're speculating here. The thing, go back and check the records for those previous events. If there were around those dates, did people report comets coming in? As far as I know, they didn't.
What about space flight during that time, or even, airplanes, commercial flights? I mean, anything like that would be affected.
Yeah, first of all, even airplane flights, you wouldn't want to be flying during this event because you don't have as much atmospheric protection. And in fact, there's cases, they talk about cases where there was a solar flare and pilots got a certain amount of exposure, like hundreds of chest x-rays just in one flight, so this would be much worse. And for sure you wouldn't want to be in the space station. I don't know, nobody seems to be concerned there at NASA about something like this happening, so I don't know.
Well,
unless they have
some
information better than we have, nothing's going to happen. There's nothing to worry about. I would, if I were them, be prepared, to send people down and not be like fried in a tin can up there, something like this.
Okay, and what about volcanism?
Well, if there was a gravity wave, it could not only trigger earthquakes, it could trigger volcanic activity. That's a possibility. It would produce, possible polar jerking. Depends on the magnitude of the event. Like a fairly large superwave could jerk the poles, and we hear about this phenomenon in myths, like the Hopi myths talk about the Earth's axis being displaced from its normal position. Well, even if this was a displacement of 100 meters, that could be a significant shakeup of the entire planet if that happened very quickly. I don't see polar flips happening where the pole was oriented 30 degrees to its present direction, like Velikovsky was talking about, or Hapgood and others. And even if you look at the comment section, some people are claiming, oh, definitely this thing will happen. The pole will flip with this coming event. They've seen this, that they may have dreams or whatever, I don't know. But looking at the past record, we haven't seen anything like this happening for the last 240,000 years. It's in the ice record, at least.
Okay.
So, I mean,
what about the effects on the sun? Because you're saying it's going to affect the Earth, it certainly must going to be affecting all the other planets, including the sun, I would think. Would it trigger, for example, a CME or a larger CME than normal?
It's possible. Could stir things up in the sun because gravitational pull on the sun itself, just like if it was pulling on the Earth, it could trigger earthquakes and volcanic eruptions. On the sun, it could stir up make it more energetic, I would think. Although right now the sun is going into a more quiescent period where it's not generating solar flares as frequently, and they're predicting that we're entering a ice age period, small ice age, not like a major ice age, but a little ice age, like we had 400 or 500 years ago. We had several of these little ice ages during the medieval period. So they're expecting that for the next few solar cycles, next 20, 30 years at least, we might have cooler climate. But that could change if you had a superwave. Maybe it could stir up some activity of the sun.
So and it could also therefore also be affecting our weather, right?
Right. If the sun's effect on the Earth would be much greater if there was solar flare, a major solar flare. But even the superwave would cause some ionization of the upper atmosphere, of the stratosphere, and that tends to generate clouds, high altitude clouds, and that tends to cool things on the planet and produce whatever that would produce, whether they wouldn't really be rain clouds, but they would have cooling effect. So a definite effect on the climate. So that could be, you know, even from a small superwave could have that. And there needs to be more work done to look at these past events. I know the one that happened 5,300 years ago. Now that one lasted up to 100 years. And there they do report a 20-year cooling period, probably when this was at the peak. So there we do know there was a cooling from even this small superwave event or medium-sized superwave event. Yeah.
Okay. Let's see. We do have people, you know, listening that do want to ask questions. I think we've been going for about an hour. So I do want to take questions in the chat here, if possible. And I'm also going to ask those people to put their questions in all caps so that I can easily see them. It's not always easy for me to read the chat because of the way, you know, I have to be doing two things at once, kind of. And the text in the chat is very very small, so I'm looking at it from a distance here. Anyway, but in terms of what you're talking about and sort of the lack of notice, I guess you might say, you're coming on my show to sort of make people more aware. We're doing sort of a progress report. Is it possible, like, let's say, I don't know, 3-4 weeks go by and there are some effects that lead you to believe that this thing really is sort of on the way? Would you be able to come on the show and let us know? I mean, will there be, because you're saying there could be like a 2-day window, is that right? Where you would know for sure?
Yeah, well, if I'm within access, email access or phone access, and I have my computer with me.
Well, I mean, would your reaction be, let's say you knew that this thing was happening. I mean, I'm not sure if there's going to be, maybe you're not sure if there's any other trigger events or something that can happen between now and then where you would know that this phenomena that you're talking about would be headed this way and could arrive, that the possibility or the probability of it happening was much greater than it is, like, say, right this moment. What would you foresee might be the effects? Well, if I had the 2-week warning, you know, maybe that would be a reasonable lead time. Where, let's say, astronomers found there was a separation of the cloud, and let's say they were up to their word and let me know, then I could say that we're in a more serious situation right now. We're going to expect something to impact within 2 weeks. But if it's visible, like a brown dwarf that wouldn't be generating enough of a cloud for them to know, we would only have maybe a 2-day warning, and it would depend on the SWIFT data. Now that comes out every day, so then there is some lag for them to get it posted and then for me to see it. So maybe from the time I see it, there's 1 day left. And, you know, it's difficult to do too much with just 1 day, you know. Well, I mean,
best, you know. But
just on the most basic level, would you say that people should, I'm going to try to go to your go to your website here. So what is the URL again of your website?
Etheric.com.
Okay. Etheric.com. So that people can, because I am looking for some of these, the pages. And if I'm on the front page, is there a way to get directly to anything without having a URL?
That's the Stargate you're hearing there.
Yeah. How do I get beyond the Stargate?
Click there, and you just click on any of the Stargate pages.
All right.
And then the news column on the left. And the last 3 news postings show up, but then to go to the earlier ones, you click on the link that says news, past news or something like that. And that will take you to all of them in the, page after page of them. And just click on the ones that you would be interested in.
Sure.
Do you see them
there? Well, yes, I'm actually bringing them on the screen, or at least bringing this on the screen, and so that people can kind of get an idea. In terms of I know you're having a lot of discussions. Are you? I mean, I hate to ask you this question again, but I'm actually sort of stunned and amazed. That all of the scientists that would have seemingly become aware of your work through your books, and you have excellent work, with regard to all of the physics that you've done. Why is it that no one? I mean, does someone come on, even under an assumed name and post in your chat room type of thing? I mean, it just. How is this possible that no one has any interest or appears to have any interest, ongoing interest, another scientist who might be sort of finding what you're doing stimulating and want to discuss it with you in even a public forum? Is there no one?
Well, I mean, I've communicated with some of them. As you saw, 3 answered my recent email. And if I was requesting papers, they were kind enough to send me their papers, at least do that. But I think it's like an old boys club, and I haven't been attending the old boys meetings. Unfortunately, that's part my fault, to present papers in the standard physics journals and attend the meetings. I just haven't had the time with other things. And now this came up. I have published papers right along, though, but not on Superwave. I had that one 87 that I published. And really, I should publish an updated version because there's so much confirming evidence that's come out since that paper was published. It's incredible. I've just tried to post a lot of it on the Superwave blog that Starburst Foundation has. There's a lot of information also on the Starburst Foundation website. And we have these forums there, and there's one dedicated to Superwave. So there's a lot of information there. I did discuss something about the M82 galaxy recently on etheric.com, how that indicates that exploding galaxy which is near us, that those cosmic rays are confirming the superwave theory, that they are traveling rectilinearly at the speed of light away from the core. So I almost, if I was a little earlier, I could have probably gotten into present a paper at the American Astronomical Society meeting in January, but I missed the date. So now I just think the best thing is just to do what I'm doing. And I tried, I'm sure that if they opened my emails, they probably read it. Maybe they were afraid to respond to indicate any interest. They're very, scientists tend to be very concerned about peer pressure. Um, and
Okay.
unfortunately, yeah.
All right. Well, at this moment, I'm going to try to grab some questions here in the chat, and hopefully I haven't, sort of, the chat seems to be changed a bit, so I'm not sure what's going on here. All right. Someone wants to know, could the moon, this doesn't seem too related, but I'll ask it anyway since it's here. Someone wants to know, could the moon be a weapon causing pole flips and massive tidal waves throughout history?
No.
Okay. What about cones, vortexes that are supposed to be by the sun in all this, by the sun? Would they get activated by something like the wave?
Okay, they would have to say what a cone vortex is.
Yeah, they put, what about the cones with cones plural and vortex? I think they meant and vortexes. I'm not sure what they're referring to either, but maybe
Okay.
maybe some of the spots we see on the sun, I guess.
Solar spots, you know, that probably have vertical motion.
Well, I mean, if the sun is affected, then anything's part of it is going to be affected, I think would be logical.
There could be some effect if it was a big superwave, especially. Yeah.
Okay. I guess somebody wants to know, could it affect our DNA?
Yeah. If it was a large superwave, like we had during the Ice Age, you would have gotten increase of the mutation rate, and not to the point of being lethal, but it would have caused genetic mutation. In fact, you see the worst, though, it happens with the solar events, you know, where the solar event will decrease the geomagnetic protection and at the same time increase the radiation exposure on the Earth. In evolution theory, now they've come to the conclusion that mutations occur in spurts. Evolution goes in jumps. They call it quantum evolution. And so this very much supports the superwave theory. I've written a paper about this, and it's published in the journal Anthropos.
Okay.
So, yeah.
All right. Have you seen Robert Felix's work?
No.
Okay. Maybe the person who wrote that question can elaborate on who Robert Felix is a bit here, and see if there might be some interest in that person's work. Okay. At the moment, assuming that I'm getting all the questions here, I don't see any other questions offhand. So if anybody has more questions, please do, again, put them in the chat in caps, and we will sort of continue for a few more minutes here if more people want to ask questions. I'm just hoping that I didn't lose any questions because I'm not sure the way this thing is operating over there. Anyway.
One of the postings I made was about these trumpet sounds people heard in 2012, in 2011, and which there's no explanation for what caused them. And so there's been a lot of discussion on that posting about dreams people have had, and so some people have reported dreams that sounded like in the dream that they were experiencing galactic core explosion. And some people get dates, they're concerned about certain dates that might be dangerous. One number that one person had been told was 17, whatever that would mean. Another person was concerned about tomorrow, actually March 5th, if something might happen. As far as the superwave, I'd say that was a little early
Okay.
to be concerned.
You know, it is interesting that we did an interview with you. I'm trying to remember the exact year. It might have been 2009. It might have been even earlier than that. At that time, if you could just sort of shift your mind back to where you were at that time, and now where you are in regard to at least the G2CLOUD and what you think may be happening, has there been a substantial shift in your own perceptions of your own work, or an expansion in that way? Or, you know, it sounds like you've gotten more validation, but has there been a substantial change from your perspective now from your perspective then to now, would you say?
Well, yeah, I mean, a lot of stuff that was coming out in the news was supporting superwave theory, and I made postings right along. And now I am more engaged in the whole thing. I consider it one of the more important projects I'm involved in, considering this window. It's sort of like after the summer, we can calm down, I believe. You know, if nothing happens, then we can say, well, that was nice. We got over that period, you know.
Okay.
So I have to admit I'm a little on edge myself. I feel responsible to let people know if something develops.
Okay. Let me see. Someone wants to know what you think of the South Atlantic anomaly and how it lets in space particles as planes fly around that area of the coast of Brazil. Have you heard of positrons? Information of positrons? Does any of that make sense?
Okay, I haven't heard about this anomaly. They're saying that the cosmic rays are coming in through the magnetic sheath of the Earth in that region for some reason.
Yeah, it looks like something around the area of the coast of Brazil, space particles where planes are flying. I actually don't think I've heard anything about it. So I don't know what that means, what they're talking about, South Atlantic anomaly. Maybe somebody could explain that, and then we could ask the question with more detail. Have you seen Susan Joy Rennison's work on space weather?
No.
Okay, I have. I think she does very good work. She's a scientist. It's been a while since I looked into her work. I was going to try to interview her, and she lives in Europe somewhere, and I think we had trouble connecting in terms of the times. All right. Is there anyone's sort of work that you would recommend that people take a look at? I know you mentioned Velikovsky. Is there anybody else or any Russian maybe work that may sort of be complementing yours or anything of that nature?
You're talking now about the superwaves?
Well, even in other areas. I mean, I know that your kinetics. I mean, you're sort of, you have massive amount of work, and we're not talking about all of that here, but I am curious. I mean, I think that people would also like to know, how other scientists are, if there are any, again, kind of getting back to this idea, but from a different direction. Sometimes Russian scientists appear to be a bit more advanced than, at least publicly speaking, than Americans and others with regard to their work in these more
subquantum kinetics,
areas.
there's a lot of scientists are very interested in it because they see the potential of the theory as a unified field theory, and it answers a lot of things that standard physics doesn't. It's had so many confirmations. Now I'll be presenting on that at Milan at the end of March. There's what's called the Exploratorium Symposium, and that's based around Ervin Laszlo's book that's come out, The Self-Actualizing Cosmos, and he invited me to write about subquantum kinetics in the appendix. As an example of an etheric physics, because he is pushing the idea of the akasha, the idea of an ether, that this is the next step for science, is to acknowledge the existence of the ether, and a lot will start becoming explained. And so he's picked subquantum kinetics as an example, which I'm very honored to. And so I'll be leading off the physics part of that symposium with the theory. And
Okay,
so
what is the
that give it a
date?
lot of exposure, I think.
What is the date of that?
I think it's from the 28th to the 31st
Of which month?
of March,
Of
so
March.
this month.
Okay.
So it'll be a Saturday and Sunday.
In
And
Milan.
if I'm not mistaken, I think there's no admission fee. So
Wow. And that's
uh,
in Milan, Italy.
Milan, yeah.
Uh-huh. Okay, very good. That may be something people should look into. I certainly wouldn't mind attending something like that. So I could look into
And
if I was in Europe at the time. Let's see. We've got some people asking. I mean, kind of this has actually been addressed, but we can address it maybe very briefly if you want. Somebody says if such an event is near, what are the best and the worst case scenarios? I think we've kind of described, obviously milder versions of the worst case. But if you want to outline, maybe they're asking for 7. I don't know if you want to go down a laundry list or.
I've given a ranking to superwaves, magnitude 1, magnitude 3, 2, 3, and 4. And that ranking is posted on the Starburst Foundation website, one of the pages there. So, like for example, the smallest type of superwave we're talking about is like what we've been experiencing the last 5,300 years. These ones that last less than a year, most of them, few of them maybe 2 years, and they don't do any kind of climatic effects. But if one of those small ones was to occur today, it could knock out the electrical grid. We might be without power for 5 or 10 years, which would make social upheaval, basically.
Okay, but you're saying that's a small superwave.
Yeah, so a small superwave would have a major effect on us, economically and sociologically.
Well, at this time, are we considering a small superwave, or when you say gravitic wave, that's not even a small superwave, that's smaller still. Is that not right, or am I wrong?
Well, you would have a gravitic wave accompanying any superwave, I believe.
Okay.
And I presented some evidence in my dissertation. Superwaves tend to trigger supernova explosions. So how is that? How would that occur? One way is if there was a gravity wave associated that would disturb a star that was like on the verge of having a supernova event.
So it could affect other bodies in our galaxy?
Yeah, and any galaxy. So I
Neighboring
believe
galaxies?
supernovas
I mean,
tend to go. Yeah.
would it affect neighboring galaxies as well? Or, I mean, I don't know how far out these effects go.
No, like there's Centaurus A is the closest exploding galaxy to our own. It's about, I don't know, 5 or 6 million light years away. So it's in our local group of galaxies. We do get cosmic rays from Centaurus A. We get cosmic rays from all directions of space, the proton component. But they found a slight enhancement in the direction of Centaurus A. And the reason is because those cosmic rays do reach us, but it's a small increase. So most of the background radiation is due to this proton component that comes from all directions. So you can say, yeah, there's maybe a 1% effect of this neighboring galaxy.
Okay, but to kind of wrap this particular question up, what you're saying, though, in regard to this thing that may happen in the next few weeks, in essence, the worst case would be a small superwave, or is that the least?
That would be the best alternative.
That would be the best alternative.
I mean, worst would be where it lasts for 100 years. And then worse than that, if it lasted for 1,000 years or even 4,000 years, like there was one that appears to have lasted 4,000 years, around 40,000 years ago, appears to have been a mass extinction in Australia at that time. So likely the Earth's orientation was such that it was the impact, if there was a solar effect associated with that, it affected the southern hemisphere more than the northern. So those altered the climate of the Earth.
Okay, are you able to say whether this particular one would affect the southern hemisphere more than the northern, or the reverse, the northern more than the southern, or is there no way to tell at this time?
Well, the galactic core is higher in the sky in the southern hemisphere. Like the northern, where if you're at 45 latitude, it's like just 15 degrees above the horizon. If you're in northern Sweden, it's below the horizon. But still,
how
even
does that,
so.
Yeah, but how does that translate? What does that mean? Does it mean it would affect that, therefore it affects everything south more so?
Well, you'd be shielded from the initial high energy component. Actually, Fred Hoyle wrote a story called Inferno, a science fiction story, about a core explosion occurring. But in his story, it was of the intensity of a quasar, which we don't get quasar explosions in our galaxy because our core isn't massive enough to produce such intense explosions. But so it was a fictional story, but he had people going up above the Arctic Circle to get away from the direct blast.
Okay.
So in the southern hemisphere, you would have that would be higher in the sky there. Yeah,
so more likely to affect, in theory, more likely to affect the southern hemisphere than the northern.
Yeah.
Although you said eventually the waves, so the sort of the energetics goes all around the Earth.
Yeah, it affects ultimately the whole planet, because the cosmic rays will get bent by the magnetic field of the Earth and captured, and then they'll be coming in all directions. You see, as you wait, like in the first 3 minutes or 15 minutes, you're getting the very high energy components. Those are the cosmic rays that arrive first. They're the ones that they're traveling very close to the speed of light, and they're the least bent by the Earth's field. But then as you wait, as time goes on and this whole phenomenon evolves, you're getting the lower and lower energy cosmic rays arriving, because after all, it's 23,000 light years they had to travel. And so, like after, some of them will not arrive till days later. And
okay, what about, is the effect escalating or de-escalating as it goes? Or do you know?
Well, you could say in a way it escalates. I mean, you get different things happening. In the beginning, you get stuff that could be very intense. In the first 3 days, for example, you're getting the highest energy component. So ideally, you'd want to be shielded during that period. But even then, it probably, it would cause genetic mutations, but it probably wouldn't kill you. I am guessing, Um,
Would crops burn, for example? Plants on the Earth, would they be affected?
those are solar catastrophes that would do that sort of thing.
Okay, so this cosmic waves wouldn't.
Yeah, think of the galactic center as like the sting of the scorpion. It's not like the dragon of the sun, if you want to make the comparison. Remember in the myth of Theven with the sun chariot, the sun got energized and made active because he drove the chariot near Scorpio, and the horses got frightened, as you recall. So it shows that, and this is an allegorical myth, it's information, important information is being handed down from our past of people that knew about this, and this whole thing was forgotten. But from the myth, you see that they recognize it's the sun that has the greatest threat to the Earth, but it's triggered by the core explosion, by Scorpius. So, you do get some effect, cosmic ray effect, from as far as mutation, but lethal effects would come from the sun, and that would require one of the more major superwaves, where this thing is happening for hundreds and even 1,000 years or more, where it's bringing dust into the solar system and causing climatic changes and affecting the sun. The dust is falling on the sun, energizing it. It's creating a cocoon around the sun and shining the radiation back onto its surface and creating sort of a hothouse effect that the radiation can't get out as easily as it did before from the sun. And so it starts inflating its photosphere and becoming more active. And then started blowing the stuff out periodically to clear the cloud away, but then the stuff comes back, So well, it's like a battle between the darkness and the light, sort of.
Okay, is the I wonder what the effect is on water of these cosmic rays. Do you have any idea? Is it, in other words, is it electrical? Is it does it heat things like water? Would it or is it just sort of stimulate it? You say it would fry satellites, electronics, and things, but is it? You know what I'm saying?
Yeah, I don't think it would be too important as far as water. It would produce ions in the atmosphere.
Is it a form of radiation? Cosmic rays?
Yeah, they're, like you'd get from an atomic bomb explosion, but not as intense,
Okay. Well, like Fukushima, I mean, what are we talking here? Because there is a lot of talk at this time, as you know.
You wouldn't have, like Fukushima, they're worried because it's producing radioactive waste that's polluting the environment. Now, you wouldn't have that, but you would have cosmic rays, like that's what the waste would give off, was cosmic rays. But in this case, much higher energy, but not as intense as what you'd have from a nuclear accident, as far as...
Well, would it affect humans? I mean, is it adverse? In other words, radiation is said to be adverse for our health, causing cancers and various things. Whether it really does or not, I'm not so sure of myself.
There's a video of a fellow who claims he used to take his morning dip in the reactor pool. They had a pool where they keep their waste. And you could actually see the bluish light from the Cherenkov radiation the waste was giving off in the water. And it was kept warm by this radiation. And he would swim, and he was fine. He died at a respectable age. And he was claiming that a lot of the concern is blown out of proportion, that it's really to make people afraid to hijack this stuff for reasons of nuclear concerns of
Yes,
making
and
nuclear
I
bombs.
posted that actually on my website, the video of him talking about that. But do you agree with that?
Um, well, you know, it's possible he's right, but you could get a lot of negative ions produced in the atmosphere
So it could be
so that
healthier.
could be healthy for you. In fact, I've heard people say that they believe that such an event will have healing effects on the people. And this is something, it's a recurring theme that people talk about for the apocalypse or dreams they've had that people will be healed. Um, so there is that aspect. Because you see, the electrons beat the protons when they come on this journey. The electrons are 2,000 times closer to the speed of light than the proton because they're 2,000 times. That's not really the way I wanted to put it, but there's a 2,000-fold difference in the mass of the electron to the proton. So because the electron is much lighter, it's able to travel much closer to the speed of light. And so what you see is for the same energy, the electrons will be first and then the protons. In fact, a lot of the protons won't even make the journey because they'll be going so slow they'll be stopped by the magnetic fields in the galaxy. So the superwave will be negatively charged primarily. A negatively charged blast of particles has a gravitationally repulsive effect when it hits us. That's why we get a radial push outward from the galactic center. And negative charges are healing. I know of at least one device that cures cancer, and it puts out pulses of negative charge.
Yes.
So who knows? There's that aspect too.
Okay. One person wants to know. This is again, if it's a short event, and I don't know what a short event is. I mean, it sounds like it could be anywhere from. Is the minimal short event 1 year or the effects of that? Or the person wants to know if it's continuous impact on the Earth. Does it go, in other words, it could last days or it's going to last years or it's going to last at least a year? Is there any way to kind of talk about how long the impact or prospective impact can be?
Yeah, well, if it goes thousands of years, it means life as we know it, you know, it's going to be totally different for generations and generations and generations. That's what our
that would
ancestors
be, I mean,
went
the
through.
bigger the event, the longer it lasts, presumably.
Yeah.
So the shorter events.
It takes longer for the core, galactic core, to calm down again and come into the inactive state. Like a small outburst, it would be like a hiccup, kind of, where it gets active for a short period and then calms down. But then it's a possibility that it's like, it's a nonlinear system. And if you stimulate a little too much, it goes into this real energetic state that lasts quite a while. And it's only until the core has blown part of itself out, because, you know, most of the matter that's in our galaxy has at one time come from the core. It's actually created there and blown out. The matter in subquantum kinetics, the theory is that matter is continually created. It's created in the Earth, in the sun, in all the stars, but it's about 100,000-fold greater creation rate in the core of the galaxy, not only because of its huge mass, but because gravity potential is so deep. And that creation rate skyrockets when the core goes into its active state, because it has to do with temperature too. Temperature is an important part of the equation. If you look at the matter creation rate equation. And this is all new physics, so don't expect to find this in the physics
Right.
books.
And you have basically been one of the first people to counter the Big Bang theory in general of the universe creation.
Yeah. I wrote a paper in '86, which pretty much demolished the Big Bang Theory. But it's sort of like Dead Man Walking. It's just Big Bang Theory keeps going as if
I
nothing.
know. Yeah. I mean, even relatively intelligent people refer to it, and I'm always sort of amazed by that. They don't seem to have gotten the message.
And even now, we have a posting about a manuscript they found attributed to Einstein that he was actually entertaining the idea of continuous creation way back in the 1930, 31. Except he had bought into the idea of the expanding universe. So he was talking about matter being created in space. So it wasn't a Big Bang, but still that space was expanding. And that matter was being created as fast as space was expanding, and therefore the density would always be the same. Well, that was the same idea that Hoyle later put out a few decades later and was disproven. That's called the steady state theory. So that was shown it doesn't fit data. So Einstein was right about continuous creation. The part he was wrong about was the expanding universe theory.
Okay.
And it's just a misinterpretation of the redshift.
Okay, very interesting. All right. Well, I don't want to keep you any longer here. We've been going for quite a while. Unless there is anything specific that you think you want to address, I'm looking to see if there anything else here that any questions we've missed, and it doesn't look like it at the moment. So, are there any sort of parting words, any advice you want to give people in terms of preparation?
Well, preparation, keep some food and gas, natural gas that, even these small burners that work on propane that you heat your coffee on, that would be better than nothing if the power goes out. Backup electrical generators with quite a few cans of gas stored in a safe place, and water. Bottles of water. So the kind of stuff they talk about also for preparing for earthquakes. And in fact, we might go through some earthquakes if this gravity wave effect occurs. So
I actually do have one last question. There's a movie out.
Batteries, stock up on batteries. Walkie-talkies, so maybe citizen band radios that work off of a 12-volt battery or whatever, off a car battery, because you might not be able to you don't know if your phones will still work.
So what you're outlining would be, just for the people listening, I've done an interview with Matt Stein, who talks about preparedness in the case of an EMP or any kind of disaster scenario. So I assume that depending on the sort of level of this disaster type of, if you want to look at it as a disaster, then you can certainly watch that video. People can watch it and get more of these kinds of pieces of advice.
Stock up your wood pile. So if you have to heat your house, you could heat it with wood in a fireplace if you have a fireplace.
Yeah. But I am curious about major volcanic eruptions, because right now we're being told it's somewhat hidden, but that Yellowstone, the supervolcano, for example, is becoming more active. And I also know, the movie Pompeii shows you what happens when a volcano, such as that particular one, I forget which one that was, whether it was Etna or what, that Vesuvius or whatever. We know that near Italy there are a number of volcanoes that are very active. There are some in Northern California and north of California as well. Mount Rainier, for example, potentially, even Mammoth. So there are volcanoes all over the planet, obviously. You've said that there could be an effect if there was a gravitic wave that then affected the volcanism and earthquakes. Those seem to sort of work together. But I was wondering whether the galactic core showed any if you checked into this, whether there has been any major volcanic activity or major earthquakes that then are aligned with this sort of phenomena. that you're checking into, the superwave?
Well, there was a big volcanic outburst during the Ice Age that they attributed the climatic change to that, but it also occurred during a superwave. So it's interesting, maybe there could have been an effect there. The way I would explain the connection is that if gravity potential, because our gravity potential that we're in, a small part of it is from the sun, this gravity potential well that pulls us towards the sun. That's only a small part of the total gravity potential that affects us. The main part is the galactic core, if you study, because gravitational force goes down by the inverse square of distance, but gravity potential goes down by the inverse of distance, so it goes down a lot slower. And for mass, it's 4.3 million times the mass of the sun, even though it's 23,000 light years away. If you do the math, you find that we are mainly, our gravity field is mainly governed by the core of the galaxy. So if there is some effect of change due to that core field that's somehow affecting us in advance, and if it becomes more negative, that's going to increase the genic energy production, not only of the sun, but of the Earth. But now we see the sun is cooling, so it's sort of, it doesn't seem to fit. If the sun is cooling down, you'd expect the opposite. So I'm not sure to really say.
All right. Okay, well, thank you very much for your time here. This is really fascinating information, and we don't know, obviously, what's going to happen. I do hope that you'll stay in touch and that we can put out information as you get it, obviously. It is interesting if people out there are listening and can pass this along to scientists and people that might be able to alert, I don't know, certain agencies or whatever. Possibly we know that this information will be seriously looked into at any rate by the secret government. Whether they decide to let people know in advance of anything is a whole another more political discussion. It appears that they won't be doing that. So this may be the only notice you have if such an event happens. Is that correct? Would you say, more or less?
Unless we have some warning coming up.
Okay. All right. Well, thank you, Paul Laviolette. I would like you to give out your website one more time. Also, maybe mention some of the books that you've written that you feel that people might look into if they want some more information about your work and to go down this road further.
Yeah, Earth Under Fire is on the topic of superwave. So if you want more background information, it's fairly non-technical. If you want more technical information, there is my dissertation, which has been updated, and it's in downloadable form for a certain price. So if you go to the etheric.com site and click on the books and videos link, there's also a video that's been produced, Earth Under Fire, which is available from Gaiam TV for download. If you join their site, you can view it. And I talk a little about the superwave idea in my book, Decoding the Message of the Pulsars, which I show that we are being warned by extraterrestrial civilizations about the phenomenon. I just finished writing a paper about this and submitted to a journal, and I'm hoping that will attract more attention. It's the sort of thing where you could say, well, these are all just coincidences, like a trillion to one, or maybe somebody is actually communicating with us to let us know about this. And that maybe if there's life out there, it's not all that bad, if they're trying to warn us about this. So,
okay, well, along those lines, do you feel that you've gotten any new warnings? And we do discuss this also in my original interview with Paul, which is available on the Camelot website. So, people can definitely look into that. But recent warnings from in this way, and have you come across anything of that nature?
From the extraterrestrial aspect?
Yes.
Well, there's a crop circle that you could decipher it, that it's talking about something happening in 2035 or 2037. I forget the actual date. And also, the superwave message, there's a pulsar message that uses the Fibonacci series as a way of encoding a date. And that comes out around the same time as the crop circle date. So whatever that means, I don't know, whether the real event will be then or now with the G2CLOUD, who knows. But if anybody, the important thing I believe is dreams. People use dreams to predict earthquakes, and if people have recurrent dreams about a core explosion, they should report it. We have a comment section where people can report their experience, especially if you're sensitive. Person's sensitive and they've had dreams, they know that they're clairvoyant and their dreams have come true. Rather, we take more look at that closer than somebody that didn't prove that have a record of
sure
good record.
Okay. All right. Well, thank you very much again, Paul. And maybe we can check in with you in the near future. Again, we'll be in touch with you, and I'm sure you'll be in touch with us if there's any overt change, anything that gives you a sort of a trigger event or whatever information you might get from other scientists about, as you said, the cloud splitting suddenly, this sort of thing. And then we'll just see what happens, I guess.
Okay. Well, thank you very much, Carrie. Thank you for having me on.
All right. Okay. Take care. And thanks everyone for listening. Bye-bye.
Bye. Events in the ice record and the tree ring record that can't be explained by other causes like supernova and so on. And they seem to match up with the dates that I was talking about way back. Now the new thing, up until recently, when people would ask me what is the chance of a superwave occurring, I would just say we're overdue for one, because if you look at the past record, over the last 6,000 years, these small events at least come about every 500 years, and we haven't had one for 700 years. So I could only say, well, maybe 90% chance in the next 4 centuries. But now things have changed with the G2CLOUD, because here we see something that could pose a threat. We're now concerned if there's a binary star hidden inside the cloud, and if so, then the probabilities go way up that something could happen. So that's where we are now. The last couple of years, we've become aware of this. Just before 2012, really.
Okay, and most recently, you sent me a bunch of links, and we did post them for people to sort of review them leading up to this discussion, I guess you might say, some background. Do you want to go over some of the background of why this might be a problem? Like, in other words, last time you described very well, I thought, the process of what happens when this body gets close to the, or sort of circulates around the galactic center,
Yeah.
if it does exist. Can you kind of go over that briefly?
So you'd be interested on the effects on the Earth, or what happens when
Well,
it gets close to the core?
yeah. What happens? First of all, what happens? What's the dynamic out in space, so that people can visualize? It helps them to visualize why this might even affect us. This body within the G2 cloud getting close to the galactic center.
Okay, well, astronomers now have come to agree that there's very likely a star hidden within the cloud. It's just that some of their theories about this are a little off. Like, for example, they are under the impression that as this star gets close to the core, that the cloud will be dissipated by the tidal effects that sort of become elongated and dissipate, which I don't see happening because the star, in my opinion, is continually generating that cloud. It's an active generating process. It's not like there's a star and just happens to be in a cloud. The cloud is not stuff that's gravitationally attracted to the star. It's stuff that's being outgassed from the star. Stars don't behave as normal when they come close to the galactic core for a number of reasons. First of all, they're being heated by the tremendous X-ray or cosmic ray flux that's coming off of the core that we can't really see. We can only infer that it's there based on X-ray emission. And hurling in at like a good percentage of the speed of light. I forget what it's posted on the website, what my calculations were. I think it was at least 10% the speed of light. So you don't have much time before it hits. So I was figuring maybe 2 days at that point. So if there was a lot of X-ray emission from that ripping apart of the planet or star, at that point, we'd have 2 days before the outburst would, if it hit the core, if it was within the capturing radius of the core. So, one way of knowing is to look at the X-ray data, and I can show you the latest. They put it up every day. Yeah, I don't know if you can see this. It's posted on the website. I don't know. This curve is from the Swift telescope.
Right. I think I have it here. It's the link you last sent me, right?
Yeah.
Okay. So
there was one that had the day before, but it's pretty much the same yesterday's and today's.
Okay.
And we don't see anything happening. It's hidden under the emission from what's called a magnetar, which is very close to the core, and it's so close they can't separate its X-ray emission from the core X-ray emission because the magnetar had an outburst a year ago, and it's calmed down, but it's still 3 times higher than the core emission, and so we'll only know if things are acting up when the core has an outburst that's like 5 times normal, at least. So as of this point, it looks like things are still calm the way they were a year ago.
Okay.
And
well, this is very interesting. Now, in terms of what may happen, are you feeling that you're still in the same place where you were when we spoke last? In other words, or do you feel that you have gained more data since then that has led you to believe, something else, or brought you down that road a little further? And if so, what would that be?
I've been interacting with astronomers about this. I sent emails back in January to about 70 astronomers who have written papers about the galactic core and G2 cloud. And I was telling him about this idea of the binary star being hidden because nobody had brought it up. You know, that there might be a binary star in there, and if so, it could get ripped off and we have an outburst. So the first 15 emails I sent out, I did them in batches. I did get 3 replies back from astronomers, and all of them were positive. They thought it was a very interesting idea. You know, I should publish a paper on it. Of course, it wouldn't have been time to publish a paper. You know, by the time it's reviewed and everything, whatever happens is going to happen. So I thought the best way would be to just email them the idea so it was in people's heads to be. And I believe that the standard assessments are a little sort of lowballing the figure. It's a lot higher than they are saying. Now, these cosmic rays would go into the atmosphere of the star and heat up its outer regions of the star envelope. But in addition, there's what I call genic energy, and that's most of the stars in the sky, they're the red dwarfs, they're entirely powered by what I call genic energy, and that is spontaneously generated energy. Now, that's a new physics concept. You won't find it discussed in standard physics. It has to do, to understand what I'm talking about, go to subquantum kinetics. And I've made a whole number of predictions based on this idea, the more recent one being the pioneer effect. I predicted the pioneer effect before it was discovered, and it confirmed what I was saying, that in the galaxy, energy tends to increase over time. The photons will blue shift, so stars will be generating excess energy. Our sun generates about 15% of its energy is genic. The other 85% is fusion, as conventionally believed. But in the case of a star, when it comes close to the galactic core, the genic energy will go way up because it has to do with gravity potential. As the star gets into regions of deeper gravity potential, more negative gravity potential, the genic energy, the formulas predict genic energy will go up accordingly. So by the time it gets to pericenter, the closest approach, its genic energy production will be tenfold higher than it was when we first discovered this star. So all this, what it does is it's energy that's coming from within and inflating the star, and this will be more important for the lower mass stars than the higher mass stars, but it will sort of inflate it and cause it to be losing its atmosphere as we observe. That's the cloud being formed. So as this comes in close to the core, the question is it really more than one star? It could be a binary star. There's a big probability that it is. If it's not 2 stars, it's very likely a star with planetary companion, like a Jupiter-sized planet. And there would be pretty much 100% chance that it had a companion, at least like the size of Jupiter or larger. Could have been, could be a brown dwarf. Maybe 50%, 60% chance that it was a star as a companion. So if so, when it comes to pericenter, there's the chance that that will be tidally ripped off and come hurling in towards the core. And at that point, there's several things that could happen. One is that it gets flung out into space as a hypervelocity star, which means it'd be leaving the core at very rapid speed. The other is it could go into orbit, in a new orbit around the core, different from the G2CLOUD orbit. And the other is that it could hit the core and cause an outburst. So that's why on my website I compare it to a pinball game. You don't really know if you hit the goal. In this case, you don't want to hit the goal. So you can only put percentages. And unfortunately, nobody has done any computer simulations on the G2CLOUD with the idea that it might have a binary star in there to see what would be the chances. They have done computer simulations on stars in general in the core, but nobody has worked on the G2CLOUD. So we're a little, without information to guide us on this. All you can say is you look in the past and you notice, well, there are these stars orbiting the core from past encounters. They call them the S stars. And there is no star in its orbit that comes closer than 80 astronomical units, which what that means is if there was a star that came closer, the reason you don't see it is either it got consumed by the core or it got flung out of the galaxy. And that's why you don't see it orbiting. Now, the one that we're talking about, G2CLOUD, that's predicted to come, about 150 astronomical units, so about twice that distance. So we're in the, close enough that it's uncomfortable, and close enough that if it did have a companion, very likely it would be stripped off. So then at that point, if it does become stripped off, and the question is, would we have warning? If it was a large enough star that was stripped off, you'd see another cloud separating from the G2CLOUD. Astronomers could see that if it happened. But if it was a smaller star, it wouldn't be putting out as much gas, and it's possible they wouldn't see any cloud, because we're talking about something that's 23,000 light years away, and these things are difficult to resolve. So if it was, for example, a planet, it could happen that it gets stripped off and we wouldn't even know it. And then the first thing we would find out when something was happening is when that planet reached within, let's say, 20 or 30 astronomical units of the core. When I say astronomical unit, I'm talking about AU, astronomical unit, is the distance from the Earth to the Sun, to give an idea. And our solar system's about 30 astronomical units in radius. So when this gets, if you can imagine the galactic core being where the Sun is, and something coming in as close as around Neptune, very bloated and getting tidally ripped apart at that point. But it's coming in.
I want to welcome Paul Laviolette. This is Carrie Cassidy from Project Camelot. We're going to be doing an update on our most recent interview with Paul, which was about in December, I believe, of 2013. So just the end of last year, and this is now March. And Paul had made a number of statements about something possibly happening in April with regard to the superwave, or what might be a gravitic wave, if I understood it correctly, coming as a result of the G2CLOUD. So right now what I'm doing is putting this graph on the screen. Maybe you can explain what this is all about and why it might be important for people to take a look at. And also, I guess before we do that, Paul, if you want to give yourself a brief introduction for the people that are not familiar with your work, that would be great.
Well, I've been researching the galactic core and superwave idea for, well, since I was doing my PhD back in the late 70s, early 80s. And it was at a time when the general opinion was that our core, if it does explode, maybe every 60 million years, so we don't have anything to worry about it. And if there was an outburst, the general view was that it would be contained in the galactic core region. It wouldn't reach us. So as if we were immune to any problems here. Since that time, we know about gamma ray bursts, which most of them come from other galaxies, and they certainly affect us. In fact, one that was from our galaxy affected our satellites. That was in 2004. We had a tsunami about the same time. Whether there was a link, we will not know, but it's interesting, the coincidence. So anyway, over the years, this is one of the main things I've been working on, and formed the Starburst Foundation for promoting this awareness, because nobody seemed to be aware that this was a threat to the Earth. Most of my work back then was looking in the past at what happened at the end of the Ice Age and during the Ice Age. And a little for the time since then, there apparently are some small events that have occurred since the ending of the Ice Age, something like 13 of them. And now scientists have begun to discover